So now the next thing that we can do is to go to the, yeah, actually I'm gonna, just in case I made a mistake, I'm gonna load the AEP intensity paradigm that was predefined. It should be, so here, got my -300 to 1000. Maybe I forgot to apply my changes. For example, you need to actually, once you made a change here, assign it to the conditions. Yeah, and this is exactly the same definitions that I did. Good. So now I've got my AEP auditory paradigm, and I go to the artifact scan and start this. No, I'm not going to start it because I think now my data are already corrected. So, but I want to actually see the artifact. So I'm going to leave this with OK. And first switch off my artifact correction. So press Ctrl E, so I can actually see the artifacts in the data, and now go back to the ERP. I can click directly the ERP button here, and this will automatically bring up the last paradigm that was defined for this data set, and go back to the artifact, and now start the scan. Yeah, and I can see now display here in the middle, and what the display tells me is how many of my trials or epochs that I want to average will be rejected as artifacts. And it does it in the way that it shows the trials in the columns and the channels in the rows. Basically, there's two channels here that have got a high amount of red, and they're quite near the top. And then I've got the slider here that tells me, that allows me to separate the good trials from the bad trials. So this slider is kind of the current threshold for anything to the right. Any trials that are to the right of this slider will be rejected. Anything to the left will be kept. And I can see down here what that means for the conditions. So how much percentage will I still have for my average? These trials are sorted in the way that the worst ones, the ones with the highest amplitudes, are at the right. And the color coding means, so for each channel and trial, there's one little box, and it tells me what's the highest amplitude for this trial in this channel. So if I go to the left here, I can see all the trials that have lower amplitudes. These are all fine. These will all be kept for averaging. And the ones on the right will be, yeah, partly removed. So some of these red ones are still in there. So if I move this slider further to the right, I would include more trials, but I would also have more artifacts that are in my average data. And if I right-click on these channels here, I can also see which ones they are. So FP2 and FP1. That's not surprising. So these are the channels that mainly pick up the I artifacts. I could drag down as well to exclude full channels from the analysis. So if I've got one channel that really spoils the rest of the analysis and all other data are fine, then I can just drag down to remove it. But in this case, I would just move the slider to the left to exclude the trials with the I artifacts, and then I can see how this threshold changes when I move the slider, and then the rest ones will be kept. So this is a bit complicated, but once you get used to it, I think it's quite intuitive and easy to use. And in the end, it will really make your data much cleaner after averaging. And yeah, there's also what you call a gradient criterion. So the grading criterion is about looking not absolute amplitudes, but instead looking at changes of amplitudes in subsequent trials. So we can see there's some that have a high gradient. So we can also right click anywhere and show this trial. And we can see that this is some sort of muscle artifact here that's happening. And if I show this trial, see there's also some muscle artifact. So I can move a bit left basically to get to a more even view, and the rest of the trials are all very, very kind of unspectacular in terms of gradients. And finally, we have a low signal criterion that we can apply. This is the idea that a channel might drop out, but this is mainly something for magnetoencephalography. So I think in EEG, that doesn't happen so much, I think, but it could also happen. So then you would see it there. Okay, that's the artifact scan. So it gives you a lot of options to clean up your data. And let me just close it for a moment, and just to see what happens, I'll now switch on the artifact correction again. So this is not my recommendation, what I'm doing now. Just for demonstration purposes, I'm going to work with artifact correction active. The recommendation is that you don't switch on, so you don't correct, but instead you go to the paradigm and reject the bad trials. This will cause the least distortion to your data. But now for demonstration purposes, I'm going to work with artifact correction and see how that affects the data. So artifact correction is on, and I go back to the ERP, and now I have still my old results for the artifact scan, but I can redo the scan now. And it will now show me a different picture because my eye blinks have been corrected now. So what I'm left with now is these kind of nasty muscle artifacts that I can remove. And I go here, the gradient, yeah, this has already been taken care of. So my muscle artifacts, you see the trial here at the edge, that's still a bit dirty. I'm going to drag this to the left to get a bit more. Now they have been removed, and I've got a very high percentage of trials that are accepted in for my average.